Okay, everyone, so let's try the question number 8. So this question has the maximum mark of the 14 points, and you can see that we need to consider the function f of x equals to 4x plus 2 over x minus 2, where x is not equal to 2. So this is a rational function, means this question is derived from the topic 2, the rational functions section. Actually, the topic 2 title is functions, and the rational function is part of that topic, right? So we need to consider this function, and question A, if you look at the question A, we actually have to sketch the graph, right? And it says that on your sketch, indicate the values of any x-intercepts and label any asymptotes with their equations. So as you know, this paper, you are not allowed to use calculator. That means when you're sketching the graph of this rational function, what you need to remember is that you have to have two branches of this rational function properly aligned in the graph, right? And also you need to identify the asymptotes properly and the intercepts properly. Then you can get the 4-5 points. Okay, but in order to identify asymptotes, what I suggest that is that you have to memorize the following formula. Okay, so this is kind of formula that you can use to identify your horizontal asymptotes. Like we have to identify the vertical asymptotes, right, and horizontal asymptotes. Vertical asymptote is quite easy to find, right? You will have no problem of the finding it, because what you need to do with the vertical asymptote is you just have to look at the denominator, then you get your vertical asymptote, right? But in order to identify the horizontal asymptote value, you have to look at the both numerator and the denominator. So that's the reason why memorizing this formula is very useful. Okay, so vertical asymptote, we already know that the vertical asymptote is same as x cannot be equal to 2, right? This is vertical asymptote. You got this value from the denominator. For the horizontal asymptote, you have to look at the powers of the first term of the numerator and denominator. And since they both have 1 and 1, you know, their powers are equal to each other, we can use the point 2, where the horizontal asymptote is same as the coefficient of the first term of the numerator divided by the coefficient of the first term of the denominator. Okay, so we can say horizontal asymptote is same as y equals 4 divided by 1 or 4. Okay, and we also need to identify the x-intercept. That means we need to identify the x-intercepts and the y-intercepts. So let's do this question below here. So for the question A, we know that vertical asymptote is x minus 2 equals 0, so x equals 2. Horizontal asymptote is same as y equals 4 over 1 or 4 using the formula. So now we are going to identify the x-intercepts. So x-intercept happens when y value is equal to 0, right? So what you can do is we can set 4x plus 2 over x minus 2 equals to 0. Then we can say that 4x plus 2 is equal to 0. That means 4x is same as negative 2 and x value is same as negative 1 over 2. So this is our x-intercept. Then for the y-intercept, to calculate the y-intercept, we have to set the x value is equal to 0. So when x value is equal to 0, the y is same as 4x plus 2 divided by x minus 2. So when you set x equals 0, this is same as 4 times 0 plus 2 over 0 minus 2. So the y-intercept, right? Y-intercept is same as negative 1. So we can say the y-intercept is same as negative 1. So we got the 4 points, right? And also, since we have a positive rational function, the graph should look like one opening to the first quadrant, right? Another one happening to the side of the third quadrant, right? It doesn't really have to always have this form, but it should have the same opening side. Okay, so let's draw the y-axis first, and I'm going to draw my x-axis like this. Okay, and we do know that our vertical asymptote is 2, so I'm just going to draw 2 like this, and I'm going to draw my vertical asymptote. Okay, and I should mention that this is the vertical asymptote and x equals 2, right? And my horizontal asymptote is 4, 1, 2, 3, and 4. Then we should have a line like this, and this is 4, and this is our horizontal asymptote, and y value is equal to 4. Okay, so this is our y, this is our x. And let's identify the x-intercept, which is the -1/2. So if this is -1, then -1/2 is about here. So it means the graph is passing through this point here for sure, right? And also we should have another intercept, which is y-intercept, and it's happening at -1. Okay, then I can approximate my graph like the graph is never passing through the horizontal asymptotes, but it does pass through these two intercept points, and then never passes over the vertical asymptote. And we should have exactly same graph on other side. So I'm just going to correct this. I really suggest that your graphs are fully showing, but just like this way, right? Graph doesn't have to have a perfect shape, but what you need to show the most is your horizontal asymptote, vertical asymptote, and two intersection points, and also the shapes of the graph. Then you can get the full points for this question. Okay, then let's do question B. So question B, it says that we need to write down the range of the function. We do know that the graph will continue all the way, right? However, it never passing through the horizontal asymptotes, right? It continues to grow to the end of the y-axis, but it never passes through the horizontal asymptotes. So what you can do is we can say that the range of the function is same as y bar y, and y value is all real number. However, the y cannot be equal to 4 because y equals 4 is our horizontal asymptote, right? So our graph never passes to that line. So we have to mention that the y values are all real numbers, but it never equals to 4. Okay, so let's try the question C, D, E, F. So we know that we need to consider the function g of x, where it is equal to x squared plus bx plus c, okay? And it is quadratic, and the graph of the function g has an axis of the symmetry at x equals 2. And the two roots of the function g of x equals to 0 are -1/2 and p is rational numbers. So question C, we need to show that the p value is equal to 9/2. Okay, for the question C, you can use a lot of different methods, and there are various methods that you can use to show that the p value is equal to 9/2. But since we know that the function g of x is quadratic, and also we know that the axis of symmetry is happening at x equals 2, we are just going to use the parabola to solve this question, or to show that the p value is equal to 9/2. So the function g of x has the first term, the highest term, as the x squared, right? The coefficient is 1 and its degree is 2. So that means And also it has a positive degree. So that means the graph opens up, right? Like this. The quadratic graph, we have a parabola that opens up. And we also know that the axis of symmetry is happening at x equals 2. So let's say this is the axis of symmetry and it's x equals 2. And one of the value is negative 1 over 2. So means if I say there is a x-axis, I'm not sure how the graph will look like, but we know the x-axis will go through this parabola, and then one of the point is negative 1 over 2, right? Then the other point that meets or that the x-axis goes through is our p points, okay? That means the difference between or the distance from the point where x equals negative 1 over 2 to x equals 2 is same as 2 minus 1 over 2. So it's going to be equal to 2 and 1 over 2 or 5 over 2, right? Then we know that since x equals 2 is our axis of symmetry, that means the distance between these 2 points and these 2 points should be equal to each other, right? That means the distance between the axis of symmetry and the point P is also 5 over 2. That means the P value is same as, since we are starting from 2, 2 plus 5 over 2, which is 9 over 2. So we have shown that P value is 9 over 2 and QED. We have finished question C. Okay, then let's try the question D. So question D, we need to find the value of the B and the value of the C. Okay, so let's do this here. So we are referring to x squared plus bx plus c. So the value of the b and the value of the c refers to these two values, right? The coefficient of the second term and the constant term. Okay, so we know the two roots, which are the x equals negative 1 over 2 and x equals 9 over 2. These are the two roots that we have found from the question C, right? Okay, then since the first term has the coefficient 1, we can just say that x plus 1 over 2 times x minus 9 over 2 is equal to g of x, right? Okay, because we know that we have to find the roots by factoring the function equation, right? Then we can say that we can expand this, right? We can expand this. Then we get x squared minus 9 over 2x plus 1 over 2x minus 9 over 4 equals to 0. Then we get x squared minus 8 over 2x minus 9 over 4 equals to 0. Okay, then we can simplify this further, right? So x squared minus 4x minus 9 over 4 equals to 0. Okay, then we know that this is equal to g of x, right? So let's rewrite this. So g of x is equal to x squared minus 4x minus 9 over 4. And since we are trying to find the b value and the c value, we know that the b value is negative 4 and c value is negative 9 over 4. So we have found our b and the c value. Okay. Question E. Now we're going to try the question E. So we need to find the y-coordinate of the vertex of the graph y equals g of x. We do know that axis of symmetry is happening at x equals 2. So using that information, we know that the axis of symmetry is at x equals 2. That means the vertex, when you think about the vertex, the x coordinate of the vertex is x equals 2. Okay, we do also know the full equation of the function g of x, which is x squared minus 4x minus 9 over 4. So since we know the x value, we can substitute this into this function g of x. Then we do g of 2, right? Then we do 2 squared minus 4 times 2 minus 9 over 4. Then we get 4 minus 8 minus 9 over 4. Then we end up with negative 4 minus 9 over 4, which is same as negative 16 over 4 minus 9 over 4. So we get negative 25 over 4. So we do know that the y coordinate of vertex is same as negative 25 over 4. Okay, so now let's try the question F. We need to find the number of the solution of the equation f of x equals to g of x. So that means question f of x, solution to f of x equals to g of x means we need to find how many intersection points are there. Okay, so number of intersection points. However, for this question, we know that this is a non-calculator paper, right? That means we cannot use the calculator. However, from the previous question, number A, right? We do know approximately how the graph does look like, right? This is how the graph look like. And we also do know that we have axis of symmetry at x equals 2. So let's say this is the x equals 2 line. Okay. And then we do know that the y coordinate of the vertex is negative 25 over 4. So that means the graph is, and we do know that our graph, the graph for the function g of x, has a vertex around here, and it will probably go through. Graph will probably look like this. Based on the question C, right? We do know the two roots of this function g of x, which is 9 over 2 and negative 1 over 2. That means definitely there is a one point that intersecting here, because the function f of x also has the x-intercept at negative 1 over 2. So we have a one intersection point here, another one here, and definitely going to be another one here. So we do have 3 solutions. Okay.